of functions, to be exact. It has to have the plus c. This is always a number, always. One comment from your homework. One comment from your homework. When we are asked to find this area that involves the x-axis, see, this is a negative area and this is a positive area. So let's say from 0 to 10. So the integral, so this is function f of x. From 0 to 10 from f of x dx. Can you just tell me what sign will this have?
Negative.
Negative, whatever. Yes, now let's take a look at another situation, because many of you made that error. So this is function f, and this is function g. What do you think about this area? I'm going to say again, let's say it's from 0 to 10. So the integral from 0 to 10 from above minus below. What sign will this always have?
Positive.
Always positive. It's an area enclosed between, or it could be among, more than two functions, between two functions or among several. So this will always be a positive number, even if it's somewhere here. Still a positive number. Okay, so please remember that. So let's go back. Which one you wanted to work with or on, the definite or indefinite? I think you said indefinite, but I'm not 100%.
Yeah, I wanted to look at one more indefinite, if you don't mind.
Yes, no, of course not. Okay, so let's take a look at another indefinite. Okay, number 30 caught my eye on page 434. Feel free to choose if that's what you want. So it's the integral from e to the x over 4 plus e to the x dx. So this is an indefinite integral. If it's an indefinite integral, it will have an answer, a family of functions, so I cannot forget the plus c. That makes it infinitely many different functions. Okay, so the numerator is one term. That really doesn't bother me. What bothers me is having two terms in the denominator, because I can't simplify. So I'll say let y be 4 plus e to the x. So when I move from this integral to an integral in y, there must be a dy here. That's why I need to find dy first. So what, can anyone give us the dy for this function? Anyone?
E to the x.
Not enough. Good, but not enough.
4x plus e to the x.
No,
E to the x over x.
no.
Or
Okay,
e to the x over y.
no. Okay, I just recycled it. I'm digging it up again. If we don't understand this, or if we have difficulties, please tell me, because this is crucial. I just mentioned this a second ago or a minute ago. When we talk about dy, if you just give the derivative without the dx, that's incorrect and nothing is good from that point on. So when we're asked to find f prime for this function, it is e to the x. But we are not asked to find f prime. We're asked to find dy. dy is what we need in the derivative. So let's give it a try again.
So would it be e to the x plus 4x dx?
So first of all, let's find the derivative. What is the derivative of this function?
just e to the x.
Perfect. And what did we say we have to do next?
dx.
Multiplied, not plus. Exactly. I know what you said, but I think I heard plus dx. Forgive me if I heard it wrong. So it's dy equals f prime of x times, not plus, dx. Okay, so when we differentiate this, we get e to the x and then dx. Good. Do I have e to the x dx in the problem? Yes. So this will be dy. This is my dy. So what do I replace this by? So this is 1 at the top. What do I replace this by?
Y.
Exactly. Because that's what it is. We just named it y. Now, let's stop for a moment. Is everything here clear? Any questions on these steps?
So why is it 1 over y?
Is this in the denominator?
Yes.
So I have to have in the denominator. Is there
Okay.
anything else left in the numerator?
No.
And I cannot
Okay.
put 0. I could never put 0. Because if I put 0, the whole thing is 0. And that's not what I started with. You can also write it like this if that's what you want.
Yeah,
That's
so
fine.
That's what I was thinking. I was just thinking dy over y.
That's fine. It's the same thing.
Okay.
Perfect. Same thing. Great. So then I need to continue here. So please stop me if you have questions, please. Okay, so what function prime is 1 over y? That's why I prepared it as 1 over y, but if it's better for you to see dy over y, it's fine too. But it's still, the function is 1 over y. What function prime is 1 over y?
ln of y.
Very good. Don't forget the absolute value. This is crucial. It's the absolute value plus a constant c. Now I have to go back and replace it. And now I know that this is positive always and this is positive always. Therefore, I can omit the absolute value. But initially, it has to be there. So I have parentheses 4 plus e to the x, only because this is always positive. Otherwise, it could have, if it can be positive or negative, I have to keep the absolute value bars plus a constant c. That's why I was hoping that you would finish this homework by today, so if you come across anything that you have difficulties with, so we can look at it. Of course, we can still do that on Monday. That's my hope. Okay, would you like to choose something else? Do you feel like choosing something else? Anything else that you encountered, or we move on? Anyone? Any questions? Is this good enough? Anyone? Please say something so I know what to do.
Yes, that is okay.
Okay, perfect. Do we want to work on other problems, or can I move on to word problems in this section?
I would be fine with going with the word problems now.
Okay, let's work on word problems, but I do have one that I just caught my eye. 60 on page 434. So the integral from 0 to 2, which is a definite integral. What will be the answer for this definite integral? For any definite integral, what is the answer? Assuming the function is continuous. Remember, the function has to be continuous on this interval. Otherwise, the fundamental theorem of calculus doesn't apply. What will the answer be here? Eventually, not right now, but what will it be? Always. Because it's a definite integral. What will the answer be?
Always a number.
Excellent. Brilliant. Thank you very much. That's all I needed. What number? We don't know yet. Good. So can anyone suggest a substitution?
1 plus x to the third.
Brilliant. Thank you very much. Can anyone give us du?
Three x squared. 3x to the x squared times dx.
Excellent, brilliant. Thank you very much. That's all I needed. Is it here? Yes. Okay, and this, of course, will be u to the fifth. Brilliant, okay? Do not copy the same limits of integration. So this is du over u to the fifth or u to negative 5 du. I'm getting it ready for the next step. Can anyone give us the lower limit for u?
Zero.
When x is 0,
Oh, 1.
1. Can anyone give us the upper limit for u?
Nine.
Excellent, awesome. So remember the power rule, plus 1 over the same number. U to negative 5 plus 1 is u to negative 4 over the same number from 1 to 9. Please leave negative 1 over 4 outside. So I plug in 9 to negative 4 minus when I plug in 1. So negative 1 over 4, and this is 1 over 9 to the 4th minus 1. I don't want to do anything with this. We can. I mean, I don't like leaving anything in the middle, but let me see what 9 to the 4th is. 6561. So negative 1/4, 1 over 6561 minus 1. Okay, negative 1 over 4, 6561, and this is 6561. So negative 6560. Okay, 6560. Can I simplify? 6560, can I divide by 4? Awesome. I will erase that. So 1640 over 6561. And that is the number. And yes, you can check with a graphing calculator. So, however, I don't need the arithmetic on a test. I'm fine. I don't care for this, but I want you to plug it in. Okay? So this is arithmetic. I don't care for it. But I want you to show me how you plug it in. Negative 1 over 4, 9 to negative 4, and then minus 1. And all this can be done with a calculator, and you can come up with that. I'm fine. I don't care for that. Sometimes I feel it takes me longer to plug in the numbers or plug in the calculator than just do it on my own. Okay. Any questions? Will you bring other questions to class on Monday if you come across anything in MyLab Math that we did not look at? Is that a yes? Is that a no?
Yes.
Thank you. Okay, so demand from marginal demand. So we are given d prime of x, negative 2000x divided by the square root of 25 minus x squared. This is what I was showing Sean. He's from my online class. Where dx is the number of units sold at x dollars per unit. So d of x units. X represents dollars per unit. Find the demand functions given that D equals 13,000 when X is 3. So sales or units per unit.
Professor, did you say 13,000 units?
Yes.
Okay.
Yes, when X equals 3. So is this problem 75? Demand from marginal demand, D prime, and where d of x is the number of units, sold at x dollars per unit, find the demand function given that d equals 13,000 when x is 3 per unit. Okay. I hope you were able to see, because with all these devices in front of me, sometimes I can't. Okay. So we are given the derivative, we are asked to find, so find d of x. How do I do this? What is the idea? What am I looking for?
The antiderivative.
Brilliant, thank you very much. So d of x is basically the indefinite integral from d prime of x dx, or simply exactly what you just said, the antiderivative. But this situation, or the antiderivative. But this situation requires substitution. I will not be able to find the antiderivative snapping my finger. Okay, so then d of x equals the indefinite integral from that, negative 2000x over the square root of 25 minus x squared dx. Yes, of course, this has no place here because it's a factor, not plus or minus, right? It's a factor. So negative 2000, the integral from x dx over the square root of 25 minus x squared. Can anyone give us a substitution here?
Professor, can you move your camera over a little bit?
Sorry. Is this better?
Yes, thank you.
Sorry about that. Always tell me. Ready. Can anyone give us a substitution? Anything?
25 minus x squared.
Of course. That's the problem. Now I need dy. I cannot start anything. I cannot change anything here before I find dy.
Negative 2x dx.
Brilliant. Please, thank you so much. Please remember dy, as you just said to me, it's awesome. I need the derivative of this function, but times dx. If the derivative will have two terms, I have to put this in parentheses. Because it only has one term, there is no need, it's not a mistake. Okay, so I'll continue here. I need the negative 2. I have the x, I have the dx, but I'm missing a negative 2. Not a problem. I can split this into 1,000 times negative 2. And I'll keep the negative 2 with the other two factors, and I will keep in front only 1,000. Now this piece and this piece and this piece are all replaced by dy. What about the denominator? Just make sure one more time. This integral has only x in it. This one has to have only y in it. Do not put any x in here. That would be a terrible mistake.
That would be square root of y.
That's it. Excellent. Thank you very much. Good. All I have to do is replace this by what? Y to which power?
-1/2.
Man, very good. It comes from the denominator. It has to be negative. Awesome.